Alright, so in lesson 3.7, we're going to talk about equations of lines in the coordinate plane. And in order to understand the equations of lines, we have to first understand the concept of slope. So the definition of slope is the slope m of a line is the ratio of the vertical change, the rise, to the horizontal change, the run, between any 2 points. So when a line contains 2 points, you take the ratio of the difference between the y values over the difference of the x values. So that's the rise over the run. So in example 1, we're going to talk about how to find the slopes of lines using that formula at the top. The slope of line A is this blue line that's increasing from left to right. So this line has a positive slope. It has the points 2, 3, and 5, 7. So I'm going to use the slope formula. I'm going to do y2 minus y1. So I'll do 7 minus 3 over 5 minus 2. Y minus y, x minus x. So this has a slope of 4 over 3. If I needed to simplify that, I would, but I don't need to simplify 4 over 3. For the slope of line B, that's the red line decreasing from left to right. That has the points -1, +2, and -2, +4. So if I do y2 minus y1, that would be -2 minus 2, -2 minus 2, and then 4 minus -1 on the bottom. So the slope would end up being -4 over 5. And that should make sense that slope is negative because the line is decreasing from left to right. If we look at the slope of line C, that's this horizontal line at the top. It has the points 1, 7, and 5, 7. So to do y2 minus y1, I would do 7 minus 7 over 5 minus 1, which is really 0 over 4. And 0 divided by 4 is 0. So the slope of horizontal lines is 0. The slope of vertical lines, for line D, that's this vertical line going straight up and down, this red vertical line, and it has the points 4, 0, and 4, -2. So if I do y2 minus y1, I could do -2 minus 0 over 4 minus 4, which is -2 over 0, which really results in a slope that is undefined. So I'm just going to use the letters U and D. Vertical lines have an undefined slope. So finding slope, given 2 points, you do y2 minus y1 divided by x2 minus x1. As a fraction, you simplify that fraction if you can. So to move ahead from that quick review of slope, we're going to talk about the different forms of linear equations. And these are forms we covered last year, so this should be at least a little bit of review. The first form is slope-intercept form, and that's y equals mx plus b, where m is the slope and b is the y-intercept. Okay? The other form is point-slope form, and that's this y2 minus y1 equals the slope m times x2 minus x1, where m is still the slope, and this x1 and y1 is a point that's on the line. So this is a nice little breakdown of the parts of point-slope form. So you might have to flip back and forth to reference this on the next page. So on this page, we come to example 2, where we graph lines with y equals mx plus b form for part A. That's that slope-intercept form. And B is point-slope form. y2 minus y1 equals the slope times x2 minus x1. So I'll help walk through each of those things. So for part A, the slope m is 2/3. The y-intercept b in this case is 1. So I graph that y-intercept. It's where the graph crosses the y-axis. That's at 0, 1. All right. A slope of 2 over 3. The rise is 2. The run is 3. So with rise over run, you always either go up or down, and you always count to the right. So for this slope, I would count up 2 and right 1, 2, 3. So up 2 and right 3. And I only need 2 points to draw a line. And when you graph a line, I want you to extend that line across the entire coordinate grid to show that this line extends to infinity in both directions. Okay? So that's graphing a line in slope-intercept form. In point-slope form, slope's given to us. In this case, for part B, the slope is 2. The point we're given is a little more tricky because it's the opposite sign of the values next to x and next to y. So the actual point for this line is -3, +3. So this +3 gives us x1. This -3 gives us y1. So when we're thinking about point-slope form, for the point, it's the opposite sign. So that's one thing to keep track of, and we'll get practice with that. So I'm going to graph that point first. -3, +3 would be this point, and counting a slope of -2, that's a rise over run of -2 over 1. So the way I would count that slope, I would go down 2 and right 1. So with negative slope, your rise is negative, you go down. With positive slope, your rise is positive, so you go up. But you always, for your run, you always count to the right to help you determine that slope. And you should know, once you graph a line, whether that slope makes sense. A line that goes up from left to right should have a positive slope, like part A. A line that goes down from left to right should have a negative slope, like part B. We'll iron out the parts where we pick out the points or we pick out the y-intercepts as we go through the practice. Okay? So in example 3, we get a couple examples of writing equations of lines. So in part A, an equation for a line with a slope of 3 and a y-intercept of 5, that's going to be that slope-intercept form, y equals mx plus b. So this equation has a slope of 3, so that's going to be 3x plus -5. So I would just do 3x minus 5. M is 3, b is -5. And I'm just writing my equation based off of that information. So that's y equals mx plus b. In part B, I'm given a point, I'm given the slope. I find the equation of that line in point-slope form. So I'm going to do y minus the y value of that point equals the slope times x minus the x value of that point. So x minus -1 is really x plus 1 because I'm subtracting -1, which means I'm really adding 1. So with point-slope form, you've got to be a little careful with the signs you give for your points, okay, when you're writing out that form. So we will get practice with this as we go through some more examples, all right? So example 4 kind of touches on that. Example 4, we're going to write in point-slope form. So we first have to find the slope. So back to that y2 minus y1. 5 minus -1 over 3 minus -2. So 6 over 5 is the slope of that line. To write this in point-slope form, I have to pick a point. I'm going to pick my point as being the point 3, 5. Okay, so my point-slope form using the point 3, 5 is going to be y minus 5 equals 6 over 5 times x minus 3. And that is my point-slope form of that line. So point-slope form, y minus the y value equals the slope times x minus the x value. For part B, we're going to take our equation from the top and rewrite it from point-slope form to slope-intercept form. And the first step to doing that is to distribute 6 over 5 through those parentheses. So this becomes y minus 5 equals 6 over 5 times x minus 18 over 5. Now, if you don't want to deal with that as a fraction, 18 over 5 is really 3.6. I'm okay with you using a decimal at that point. So then all that's left to do to convert this to slope-intercept form is to add 5 to both sides. So it's y equals mx plus b. And I would be fine with you giving me that as your equation in slope-intercept form. So I may ask you to convert point slope to slope-intercept. So just be aware how to convert between the two forms, because y equals mx plus b is what we are going to use the most often, okay? So point slope form, I'm still going to have you practice it, but understand slope-intercept form is going to be the most common, okay? So last example, writing equations of horizontal and vertical lines. So the equations for the horizontal and vertical lines through the point 4, negative 3. I'm going to graph the point 4, negative 3 first. Use green to do that. So the horizontal line that goes through that point is this horizontal line. I'm going to draw it in blue. The equation for that horizontal line is y equals negative 3. Okay, so y equals a constant. Tells us we have a horizontal line. Vertical line that goes through this point is going to be a vertical line. I'll do that a little bit better. Straight up and down line. And the equation for that line is x equals positive 4. So x equals a constant is a vertical line. So I know these notes were long, okay? Sorry for sticking you through that, but review of drafting these lines is important because we're still retaining some of that algebra we had from last year. So you're ready to go on to the practice I've got for you? We'll do more of this Friday to help review before we take the quiz.